This video is for Chapter 5, Section 3, and it will be about concurrent lines. We're going to define current lines at the end of the lesson as being three or more lines that intersect in the exact same point. Two lines will always intersect at one point, but when we have three or more lines that intersect at one point, we consider this to be special. The way we're going to find out about concurrent lines is look at the different special lines within a triangle. There will be four major lines that we're going to look at. The first of which is a median. Now this is a new term for us. A median is a line from a vertex to the midpoint of the opposite side. The primary goal of this video is just to get the definitions and to then be able to visually see a median within a problem. So, if we take this definition of a median, a line from a vertex to the midpoint of the opposite side, the key word here is we must be able to see a midpoint. So if I start off with my acute triangle and I put in a point here and I mark that point as a midpoint, I can now draw a median. I can pick the vertex that is across from it and connect to that midpoint. Now that is not a very well drawn median, but it can work. It goes from the vertex to the opposite side. Now I can do this for all 3 points. Another midpoint, therefore another median. A third midpoint, and I can connect this point to the vertex. Now, if we've done a good job at connecting these medians, we will see that they all come together at the same point. Now, this is the case for the medians of any triangle. Although the work you'll be doing in class is to draw in the rest of the lines, I have now done it for the acute triangle. I will look at one version of these on each of these other triangles. For example, on the right triangle, maybe we did this side here, and we find our midpoint, and we mark it. Now we know this is a midpoint, so we can connect that midpoint to the vertex. Vertex to a midpoint. This is a median. I'm not going to draw all three, but if I did, they would all intersect at one point. That point is going to be called the centroid. The centroid of a triangle is its balance point, and we'll be talking about this more in class. It is always inside the triangle. The centroid, or the meeting point of the medians, is always inside the triangle. Let's move on to our second point. Our second line. Our second line is altitudes. By definition, an altitude is a line drawn from a vertex perpendicular to the opposite side. Now, the word midpoint is missing. The key word now is perpendicular, which means I'm looking for right angles. Again, I'm going from a vertex, and this time I'm going perpendicular to the opposite side. So I'll start again with my acute triangle, and I'll put my dot here. That's my vertex, but now I want to go perpendicular to the other side. So I just want to go straight down and form a right angle. This can be done from the other points on the triangle simply by rotating your paper so that you can draw straight down. I can't exactly rotate my screen, so I'm going to have to be good at this. I'm going to have to pick this point, and I want to draw perpendicular to the opposite side. Estimating right angles can be very difficult. I suggest you use a piece of paper. Take that piece of paper and slide it along one side of the triangle until that paper hits the point. Now this paper, being a white piece of paper, wasn't very good, but you can use the corner of any object to help you create a right angle. Now, here's the third one. Vertex perpendicular to the opposite side. It is very important that if you are drawing an altitude, you include the right angle. If you do not include the right angle, you have not given anyone looking at the picture the justification that it is an altitude, that it is perpendicular to that opposite side. Again, we notice that all three of these seem to come together at the same point. Where this becomes unique and odd is on the right triangle. Now the right triangle, if I try to draw perpendicular from this point, it appears that that side of the triangle is already the altitude. This side of the triangle is already an altitude. The only side we have to work on is that one there. Now, all three of these altitudes are still coming together at the same point. They happen to be coming together right there on the right angle of the triangle. Then we have the altitude for the obtuse triangle. Now, the one that I wanted to draw, which is the most important, is the one from here. We'll discuss the others in class. I have to go perpendicular from this point. The problem is, if I go inside the triangle, that's not going to be perpendicular. Instead, I will extend this side outside of the triangle. And then I can draw perpendicular. So it's not just perpendicular to the opposite side inside the triangle, it's perpendicular to the opposite side extended. And here is an altitude. That is the most important one from the altitudes on an obtuse triangle. This one will also be difficult because it will come this direction, which we will see more of in class. Here's our definition and a few examples. The point where these come together is called the orthocenter. And it is sometimes inside, sometimes it's on, and sometimes it's outside the circle. Right, not the circle, the triangle. Here, inside, here it is on. On these, they will all come together outside the triangle. We will look at this more in class. Let's go to our third line. Okay, our third line is angle bisector. This is a definition that we already know. A line from a vertex that bisects an angle. The key, bisect an angle. No perpendicular here, no midpoint here. We just need to bisect the angle. These can be done very quickly. Pick any point on the triangle and draw a segment. As long as we then mark that we bisected the angle, we've done an angle bisector. Take our vertex point, bisect the angle, mark it so that it's different than the previous one. Take our vertex here, bisect the angle. Accuracy is not the issue as much as making the marking so that we understand. Again, these come together to form one point. This point will have a name. This will be called the incenter. If I went to the right triangle, I could bisect the right angle. I could also bisect any other angle in the triangle. Now, notice these are coming together inside the triangle as well. On the obtuse triangle, I can bisect the big obtuse angle, or I could bisect one of the smaller acute angles. Again, coming together inside the triangle. This point where they come together is called the incenter. And the incenter will always be inside the triangle, no matter what. Now I don't know if my board will allow me to draw this, so if not, I'll try it on the whiteboard. But the incenter of the circle is very cool, or the incenter of the triangle is very cool. It represents the center of the largest circle that can fit inside the triangle. And so if I drew a circle that went like this and could fit inside that triangle, just barely sliding through, that would be the center of that circle. And it represents the largest possible circle that could go through the triangle. That's what the incenter does, and why this incenter is always inside the triangle. Let's see if we can scroll down to our final line. All right, our final one for today is perpendicular bisector. Again, a term we already know. A perpendicular bisector is a line from a midpoint of a side of the triangle and perpendicular to that side. Holy cow, we got two important words here. Midpoint, we better be able to see that. Perpendicular forms a right angle. There is one word that's missing here. Vertex. This is the first and only line that doesn't go through a vertex. So for example, if I needed to find the perpendicular bisector, I might first find the midpoint, and then I just go perpendicular to that point. Well, that definitely did not go through the vertex. Now, there are times when it might go through the vertex, and we're going to discuss that in class. But here, again, just the basic definition of the perpendicular bisector. It did not go through the vertex. If I make a second example here, I start with a midpoint, and then I take that midpoint and I draw perpendicular to it. Make the right angle to show perpendicular. Now notice this point here is coming together inside the triangle. Although this is not drawn very well, it shows us that the intersection point of the perpendicular bisectors will always come together, all three of them. One of the ones that I think is most interesting is go to the obtuse triangle, in which, if I find the midpoint and I go perfectly perpendicular, and then I find this one midpoint, mark it, go perpendicular. Notice they come together outside the circle. Now, I have not drawn all three. This is part of the work that you are going to do. You'll have to put the third one in and extend it backwards to get that intersection point. You'll have to put the third one in and you'll find that they all hit the same. One of the most unique ones is if you do a right triangle correctly, midpoint, and draw perpendicular, and go to here, midpoint. Now I'm just estimating, but if I estimated correctly, a very unique situation to the right triangle is that the point where they came together was on the triangle. So this special point, the final thing for today, is called the circumcenter. So let's see if I can write that in here. Circumcenter. And in this case, it can be in, on, or outside the triangle. Just like the orthocenter was in, on, or outside the triangle. Now, just a brief little information about that point. That point represents the center of a circle, the smallest circle that can fit around the triangle. So for example, this point here as our circumcenter would represent the circle that would hit all three of the points on the circle. And it represents that smallest circle that would perfectly hit all three. Even this point here, even though this would be a really large circle, it might go like this, hit that one, and go all the way out there. Oh, it went off my screen, so I couldn't get the circle to go. This is an example of the circumcenter different from the incenter. To finalize this lesson, this was about concurrent lines. 3 or more lines that intersect in the same point. We just learned that triangles have medians, altitudes, angle bisectors, and perpendicular bisectors that are all concurrent. This is the basic definition of these lines and visuals for you to work with. We will now extend this in class as to how to draw these, construct these, and work with these special points. That's it for Chapter 5, Section 3.